All right, you guys, so let's start with, let's just first graph the cosine. Let's go see. Let's get rid of the sine here, and we'll just graph the cosine of x, okay? And let's see what this looks like. All right, so we've got one thing going for us. I don't think we have to shift it left or right because as you can see here, the top part or the highest point of the cosine graph is in the middle, and that is where it should be. So it does look like it's been stretched and shifted. So let's see. This, it looks like we've got to figure out halfway. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4. 1, 2, 3, 4. So this is halfway. So it looks like our amplitude is 1, 2, 3, 4. So our amplitude is 5 maybe. 1, 2, 3, 4, 5. So our amplitude is 5. Okay, so we need to put a 5 in, in front. So 5 times cosine of x. So it looks like we're going to stretch it by 5. And then are we going to move it? Are we going to shift it down? We must, because normally if this was our middle, our amplitude would be 1 and it would be here at -3. So it looks like we've shifted it down 4. Does that seem right? Because if we moved it, if we shifted it down 4, because, and you guys, the reason I'm thinking that is if I had not, let me get rid of some of this so you can see what I was thinking. If I had not made it taller, the middle would still be 1, 2, 3, 4, 5. The middle would still be here, but it would only go up 1. So it would only be up 1 here. So normally it would be, that top part would be here. So how far have we shifted it? We've shifted 1, 2, 3, 4 down. We've shifted it 4 down. So let me show you what that looks like. Let's shift it down first so that I can show you what I was talking about, and then we will make it 5 times bigger. So let's shift it down 1. So we'll do the cosine of x minus, 4. I said 1, I don't know why. 4. So let's see what that looks like. Okay, I've shifted it down 4. And now let's stretch it by 5. Okay. Should I just do a whole new one? Let's try that. 5 cosine of x minus 4. There we go. Now you can see why we shifted it and moved it down and what that looks like. So this is definitely the one that we have. So we've got it right. Yay, fireworks. I wish I knew how to graphically make the fireworks show up. Okay, I think we have one more question, don't we? Yes. Given the graph of y equals g of x below, sketch the graph of y equals g of x minus 1 plus 2. So this means we're going to move to the right 1, and this means we're going to move the graph up 2. So each point is going to move to the right 1 and up. So this point is going to move to the right 1 and up 2. So this point here is going to move 1 and up 2. This point is going to move 1 and up 2. This point 1 and up 2. So what does that look like? Let's delete. Let's erase this here so that I can just connect those points. And whoops. Cool. I know that doesn't look great because it's kind of like weird because I don't you know, have a ruler on here. And let's see the other one in, I don't know, it's bright blue. Yeah. -2 times this g of x. So we're just going to we're going to stretch it and flip it over. So if we just flipped it over, this point stays the same and over the x-axis, because every output that was positive is now going to be negative, right? This was here, now it's going to be here. This was here, it's going to stay. Okay, so we have these points now. So I've flipped it over, but I still have to stretch it by 2. So that means each output is also going to be multiplied by 2. So this was 3, or this was down 2, but if I stretch it by 2, it's going to be actually 4. Same here. 4. This was 0, so those don't get, these are 0, so they don't get changed. So what this looks like if I flip it over and stretch it by 2 is, oops, there we go. Ha! All right, that's the last one I'm going to do on this video, because I'm going to close up and go home. And when I get home, I will upload these and I will find some more angular velocity for you. I hope you're having a safe Halloween, and I will talk to you later.